Hey, what's going on everybody? So today I'm going to show you how to configure up VLANs on your Edgerouter X. Now the Edgerouter X is the router that I'm going to be using, but this really applies to any of the Edgerouter line. The commands we're going to be doing is the same, however I am going to show you kind of how to do this in the GUI first. You can do this through the GUI, but I would recommend pairing it with commands, and the reason being is because when you make changes in the GUI, unless you're doing it in the command tree section, which I never use honestly, but if you're using the drop downs on like the dashboard to change IPs and change those kinds of settings, you have to save them for each window, and then that makes the changes apply automatically. However, you'll see when we get into this that there's a couple of changes that we need to make simultaneously, or else you're going to lock yourself out of your router. So when we get to that point, I'm probably just going to hop into the command line and show you that. But there are two ways to do this. You can either do it through the GUI or the command line. Now first off, let's kind of go into what VLANs are, or why you would even want to put them on your router. So let me just draw out a typical network, probably what yours looks like right now. So you've probably got your router, your Edgerouter up here, probably connected to a switch maybe, unless you're just running everything off your Edgerouter. Either one is fine. And then your hosts down here. And they all point to their default gateway right here, probably something like 192.168.1.1. And everything's all good, but maybe you want to segregate your traffic a little bit, like have one network for just your devices you use every day, another network for maybe your Internet of Things, like a Nest thermostat, stuff like that. Maybe another one for some public servers if you're hosting stuff out of your house. Another one for just guests so they're not able to access all of your resources on your home network just because they came over to have coffee with you. Typically you would do all of this by having just multiple networks with like multiple routers. So have a bunch of routers all connected to a bunch of switches, and then you just have your guests hang off of one, your Internet of Things hang off another one, and your devices that you want to use every day hanging off your third one. Now we can actually accomplish this same thing just by running a few commands on the router, and this is going to be done through VLANs or virtual local area networks. And they're called virtual local area networks because you're virtualizing what I just drew, the three separate routers. You're doing that all on singular devices. And how it does that is by attaching a tag to the end of the traffic. So say you've got your like standard Ethernet frame, a VLAN is going to attach just a little bit more onto that with an identifier. That number is going to be 1 through, I believe, 4096. You can pick any of those numbers, and that's how it differentiates which network it's coming from. Now, a few things that you need to have to make this work. Obviously, number one for anything is a default gateway, which when you're dealing with VLANs in this kind of configuration we're going to be looking at here, you're going to be doing this with a virtual interface. So Cisco calls these interface VLANs, but everywhere else, including Cisco, calls them switch virtual interfaces. Now also, if you're using say a Cisco router on this, you would use something called a sub interface, which is basically the same thing. What all of these are going to do is it's going to correlate traffic with a certain VLAN tag with a certain interface and subnet. So what the router is going to do when you connect it to the switch is you're going to be sending your traffic down that link to the router with VLAN tags. So we'll use like a tag of 10, for example. And your router is going to have multiple interfaces on it looking for different tags or none at all. And we'll get to that as well. So say you've got one set up for 10 and like 20 and 30. Once the router sees this traffic with a VLAN tag of 10, it's going to accept it on the interface that corresponds to it, and therefore use that IP that you've configured on it. Now the second thing you're going to need is interfaces configured for a certain VLAN, as well as what's called a tagged port, or in the world of Cisco, a trunk port. So basically assigning an interface to a VLAN is going to be done on your switch. So say you've got port 1 and you want it to access VLAN 10, and then you've got like port 5 and you want that to access VLAN 20. Say VLAN 20 is for your guests and VLAN 10 is for you. You simply go into that interface's configuration, assign it to a VLAN, and now any traffic that goes in on that interface is going to be associated with a certain VLAN, which is all fine and dandy. You can have just a bunch of ports assigned to a bunch of different VLANs, and they can all talk between each other if they're on the same VLAN, but they're not really going to be going anywhere. So the way we push this traffic out to get to a default gateway or a router or something is by using a tagged port. And that port is essentially a member of whatever VLANs you want it to be a member of, except when it sends the traffic out, this is where it's going to attach that tag. Just by assigning interfaces to a VLAN does not mean that any tags are being created anywhere here. It's when they traverse outside of the switch with a tagged or a trunk port that they actually get this tag assigned to it. So you can tell this trunk to tag traffic from all of your VLANs, and it'll attach it when it goes out. And that's the traffic that your router is going to see, and that's what it's going to correlate between its different sub interfaces. Because when you create these virtual interfaces on the router, you're also going to assign a VLAN number to it, and it has to match for the VLANs that you configured on your switch. Now, kind of a bonus topic, but also a very important thing to know because it impacts this configuration very heavily, whether you use it or not, is what's called in the Cisco world a native VLAN. And it's configured on the Edgerouter as a PVID or a port VLAN ID. It's basically the same thing for a regular port and assigning it to a VLAN. What this is, if you put it on a tagged port, it's the VLAN that it is not going to tag. So if you have a tagged port over here sending traffic to your router and it's tagging for VLANs, say 10, 20, and 30, if you assign the tagged port a port VLAN ID of 10, it is not going to attach a VLAN tag to VLAN 10 traffic. So VLAN 10's traffic is going to go out just like normal, and 20 and 30's traffic is going to go out with that extra tag attached. That is what a native VLAN is, or a port VLAN ID, and that is very important. Because if you set up your router with sub interfaces, and your router has a port VLAN ID of 20, and then you have your interfaces, so like 10, 20, 30, we'll just assign these random IPs. I just noticed that my actual 20 was off the screen there. So say this is like 1.1, 2.1, 3.1. When your switch sends traffic tagged for VLAN 20 and your router gets it, but it's expecting VLAN traffic 20 to be untagged, it's not going to process it on the correct interface. And if these are the only ones you have configured, it's not going to process it at all, because your router is expecting no tag for its VLAN 20 interface, and your switch is sending a tag. And also vice versa, if your switch is sending VLAN 10 untagged, your router is going to get it and assume that it's for VLAN 20's interface, because that's what it's expecting untagged traffic on. In the Cisco world, this would be called a native VLAN mismatch, and a switch would throw a ton of console messages at you telling you that this is the case. And this is why, because it can create an issue. This is also a security vulnerability in the real world, where if you have mismatched native VLANs, switch traffic coming from one could hop on a completely different VLAN over here, and likewise the traffic coming from that switch could hop on a different VLAN over here than it's meant to, because you have a mismatch on these IDs. So let's bring this back to our home network and what that's going to look like here. So you've got your Edgerouter up here, and your switch, and then you've got 3 clients. So say one of these is going to be you, and then a guest, and we'll just pretend this is some Internet of Things server of some sort. Say you want to segregate them all into different VLANs. So the first thing when dealing with an Edgerouter is you're going to have to enable what's called VLAN aware mode. So you're going to have to make the Edgerouter VLAN aware, and then assign virtual interfaces for these 3 networks. Now we're going to come up with numbers, and we'll just make this random, sort of. We'll say VLANs 10, 20, and 30. So we've got to assign these network addresses. So we'll say 10, we're just going to put that on like 192.168.10.0, and we'll just say 20 is on 20 and 30 is on 30. Now if you want to keep your existing network like 192.168.1.1, that's probably the address that's already configured here. You can do that, you just have to move it to a virtual interface. For some reason on an Edgerouter, you still have to move your virtual IP to a virtual interface, even if that is what you're going to be using for your untagged VLAN or your port VLAN ID native VLAN. It still has to be assigned to a VLAN sub interface on an Edgerouter. Which that is where the command line thing comes in, where you have to do a few commands simultaneously in order to make that work. Because if you're moving an IP address, you have to take it off of the old interface first and then apply it to a new one. And when you're working in the GUI, you can't really do that at the same time. You have to remove it from one, at which point you will break your access. But if you're setting up all new networks, you don't have to do that, which is what we're going to do. And also we're going to have to set up DHCP scopes for each of these new networks, as well as make this port here connecting from our switch to our Edgerouter a trunk or a tagged port, and assigning each of these interfaces on our switch to a VLAN. And also we're going, because we're using a Cisco device here, the switch we're going to be configuring is Cisco. So if you're looking for a Ubiquiti Switch configuration guide, this is not it. But the same concepts do apply. But we have to actually put these into the switch. So basically creating VLANs on the switch. I assume that on Ubiquiti equipment, if you assign a port to a VLAN, it'll probably do this automatically for you. Actually, it'll still automatically do that on a Cisco switch. However, it's best to hard code them in there anyway. Now, another important note is that it is very easy to break your access to your devices while doing this. So we'll do this as an example. If we configure our sub interfaces on our Edgerouter first and assign them different IPs, make it VLAN aware, all of that, we are most likely going to break our access to the Edgerouter for the time being. Unless we do it completely right the first time, which is, it can be done, but it's probably not going to be done. And also, if you're running through your Edgerouter to get to your switches management, you're also going to break management of your switch. So most likely one of these devices you're going to want to have a secondary way into it in case you mess something up. So now that we've kind of gone over the basics, let's just jump right into the configuration. Go to my Edgerouter, which is 192.168.1.1. I'm going to log in, and you can see a pretty standard config here. So we've got 192.168.1.1 assigned to switch 0, and then our internet interface over here. Now I'm going to log into my switch as well just to show you what that setup looks like. Alright, so on my switch here, these are the three interfaces we're going to be using. Interface 1015 is the interface that this computer I'm on is actually connected to, and interface 1024, well, up here, this is the interface that's connected to the Edgerouter. So both of them are in a default configuration. Now on a Cisco switch and most other switches, the default configuration just means that it's an open port and it's technically assigned to a VLAN of 1, and it's also untagged. So basically a default is just it's assigned to VLAN 1 and its native VLAN is 1. So this doesn't pose a problem to us just yet. Now the other port that we're concerned with is going to be my port channel 1. We can think of this as a connection to another switch. This is where our other clients in VLAN 20 and 30 are going to be. And you can see it's already set up as a trunk or a tagged interface. Its native VLAN is 88, and it's trunking for 50, 66, 77, 88, 99, and 100. And actually, I'm going to call an audible here. We're not going to be using VLAN numbers 20 and 30 for our Internet of Things and our guest network. I'm actually going to be using 50 and 100 because I just remembered that I already have my hosts configured on VLANs 50 and 100, and they're hanging off the switch that this thing is going to. So this is what an interface would look like between switches if you have multiple. But we're going to be configuring 15 and 24 from scratch. Now, actually, before we get into the Edgerouter configuration, I'm going to go ahead and pre-configure my switch because I'm going to try not to lock myself out of these things by changing VLANs. And since I can only get to my switches management through my Edgerouter the way it's set up, I need to configure that first. So we're going to go ahead and go into configure terminal mode, and we're going to go into interface gig 1024, which is going to be our tagged port to the Edgerouter. So I'm going to go ahead and give that a description of tagged or trunk to ERX. Now we're going to configure this in order to not break anything. So we're going to do switch port trunk encapsulation .1q. .1q is the protocol for VLAN tagging. It's a .1q tag. That's the it's the 802.1q is the standard that governs VLAN tagging. So that just enables that protocol on the interface. And then we're going to do switch port mode trunk. Now we're going to see a little bit lag in traffic here. It's probably going to look like I'm locked out. Port's going through its... I had to shut the port and bring it back up, so we're just going to wait for that to happen. And we just got kicked out, so let's go back in. And we're back on 1024. So if we do a show run of interface gig 1024, we can see that it is now a trunk. It's tagging traffic. Now by default, it is not tagging VLAN 1. So since we're plugged into 1015, which is still a default port, it is technically a member of VLAN 1. And since changing this to a trunk has a native VLAN of 1, we're not really changing anything about the way it behaves yet. Now by default, a trunk port is going to tag VLAN traffic for every VLAN that is configured on the switch and that's going through it. But if you want to limit that down, you can do a trunk or a switch port trunk, allow VLAN, and then the number of the VLANs you want to allow. Now, since we are using VLAN 1 by default, we need to include that. So VLAN 1, and then 55 and 100 are going to be our other VLANs. Now, I know these are already configured on the switch, but what we would do to configure them is just type in VLAN and their number, so VLAN 55, then you can assign a name to it. So we'll just put the name of Internet of Things for VLAN 55, exit out of that. If we do VLAN 100, and change the name to guest. Nope, I already have a guest VLAN, that's 99, so guest 2. And if we do a show VLAN brief, we can see all of our VLANs here. So we got our VLAN 100, guest 2 that we just configured, and VLAN 55, Internet of Things. Now, we haven't assigned them to a port yet, so they don't show up over here yet. Now, the only thing we're going to have to do later is change our port 1015 to access a different VLAN. Actually, speaking of that, we didn't create VLAN 10. That's going to be our new home VLAN. So like I said, there's two ways of doing this. You can keep your original VLAN the way it is with the same default gateway, keep it untagged just by using that as the native VLAN throughout your network, or you can just create a new VLAN with everything else, which is the way we're going to do it here. There's multiple ways of setting this up, but the concepts are all the same. So we're going to create VLAN 10. We're going to give that a name of home. Do a show VLAN brief, and you can see it's right here, 10 home. So I'm just going to go ahead and allow VLAN 10 as well on here. On a Cisco switch, it's switch port trunk, allowed VLAN add if you're wanting to add one. On a Cisco switch, if you just type in a single VLAN without the add keyword, it is going to default it to only that VLAN. So that is one way that I could lock myself out here. And go ahead and write that. I'm not going to spend too much time on the Cisco device since this is more about how to set it up on an edge router, but it's good to see the switch configuration anyway. So the first thing you're going to want to do is add your VLAN interfaces. So right here, under Add Interface dropdown, you can add a VLAN. Now the VLAN ID, this is going to be the number of the VLAN you're associating it with. So we'll start with VLAN 10, and when it tells you to select an interface, select switch 0, and we can give it a description. So I think we gave it a description of home on the switch, so we'll keep it the same, and assign an IP address manually. Now this is where you can get creative. You create your own networks for these. So I said we're going to create 192.168.10.0, and that's going to be a /24. Like I say in my other videos, if you don't know subnetting, Google that, kind of read up on it if you don't know how to just create a network out of thin air. I do plan to do a video on that in the future, but that's a pretty deep topic, so I haven't done it yet. Now if we save that, so you cannot assign an IPv4 network address as an IPv4 interface address. What? Oh, yeah. So that's the network we're going to use, but we have to actually use a valid IP. So 192.168.10.1 is going to be our default gateway for the 10 network, and that's what we're assigning to this interface. So go ahead and save that. And you can see down here we created an interface called home, switch 0.10, corresponding with VLAN 10. It is a VLAN interface, and we have an IP on it. So let's go ahead and add another VLAN interface for 55. Assign it to interface switch 0, give it a description of IoT, I believe, Internet of Things, and assign that an address. So we'll do 192.168.55.1/24. It's a good idea to keep your networks somewhat corresponding to your VLAN numbers. It just makes management that much easier. And we'll go ahead and add our last ones, VLAN ID of 100, interface switch 0, description, that was the guest network, I believe, and give that an address of 192.168.100.1 and /24. Save that. So now we have all of our interfaces assigned properly. And actually what I'm going to do, just so I don't break access, is I'm going to add a VLAN interface for VLAN 1, assign that to switch 0 as well, and I'm just going to name it test. This is in case things go wrong. I'll give that an address of 192.168. This has to be 2.1. Go ahead and save that. That is the one I would like to have the same IP as this one, but since this is already active, we can't have an IP address on the same network on two different ports here, if it's not already a part of a switch network. So now that we have those set up, we could just go ahead and finish it out, but I want to create DHCP pools for all of these new networks. This is good to do first, just so you can grab DHCP automatically. So for our home network, we're going to put that on the subnet 192.168.10.0. This is where you use your network address and not a valid IP. We can tell it where to start this range, so 10.10, and we'll stop it at 192.168.10.254. Default router, this is going to be the default gateway for this network, which is 192.168.10.1, the IP we configured on VLAN 10's interface. And we can assign DNS server, so 8.8.8.8 is good. Go ahead and save that scope and add another one. So for Internet of Things, subnet 192.168.55.0/24. We'll use the same range and the default router 192.168.55.1 and DNS and save. Same thing for the guest, 192.168.100.0/24, 100.10, 100.254, and a default gateway of 100.1. DNS, save, and I'll go ahead and make one for the test network and save that. So now we are ready to make this router VLAN aware. So if we go to our dashboard here and go to our local interface, which is switch 0, the main switch interface, go to configure, go to the VLAN tab, and we have our VLAN aware setting here. Just change that to enabled, and this is where we get to assign port VLAN IDs and VLAN IDs for every port on the router. So definitely leave Ethernet 0 unchecked. That is our internet interface. We don't want that participating in the switch network. So Ethernet 1, this is our interface that's connected down to our switch that we just configured, and we need to assign it a port VLAN ID and the VLAN IDs you want it to tag. So remember that a port VLAN ID is technically the native VLAN or an untagged VLAN. So for this, I'm going to put in VLAN 1. So anything for VLAN 1 is going to be coming in untagged by expectation. And the VLAN IDs we want to participate here are 10, 55, and 100. So this port is going to tag and expect traffic for these VLANs to also be tagged for 10, 55, and 100. Now Ethernet 2, if we just want this to be like something for a desktop, we want to assign it to one of these VLANs, we just put in a port VLAN ID of, say, 10. Then I can hook up my laptop or something to that port and it'll be a part of the VLAN 10 network, which is our home network. And save that. And at this point, you're going to get kicked out because we just changed the entire configuration of the switch interface on the Edgerouter. So now the traffic on Ethernet 1 coming in, it is expecting tags for VLAN 10, 55, and 100. And our untagged VLAN of 1 has now changed networks from the 192.168.1 network to 192.168.2. So let's bring up a command prompt here, do an IP config release, and an IP config renew, and see if we can grab a new DHCP address. Now it might take the router a couple minutes to actually go through the configuration and save it to itself. So don't get too impatient. However, if after about 5 minutes you still can't access it, then call your emergency numbers. But looks like right here, we now just got access again. So you can see we grabbed an IP address from our test network. That's why I created that, so I didn't completely break it. So we got 192.168.2.10, first available address in the scope, and 2.1 is our default gateway. So we've now moved networks from switch 0 to switch 0.1 VLAN 1. So to get this computer into our home VLAN, we need to go back to our switch, so I'll go ahead and log into that real fast. So here's the configurations for those two ports that I had before. This is the one we just configured. If you want to take a look at the configs and maybe it makes more sense to you now, we got our encapsulation mode and our allowed VLANs, 1, 10, 55, and 100. And since there is no trunk native VLAN, it means by default VLAN 1 is untagged, which is why we are still able to get into our Edgerouter, because we set this port for VLAN 1 untagged, and we created a port VLAN ID on the Edgerouter of 1, which means that it expects that VLAN's traffic untagged. Now we need to go into interface 1015 and assign it to a VLAN. So on a Cisco switch, it's switch port mode access and switch port access VLAN, and we'll do 10 because that is our home network. Now as soon as I hit enter on this command, it's going to break my computer again. So switch port access VLAN 10, and I'm now locked out of the switch because I broke my own connectivity. So let's go back to our command prompt, do an IP config release, and renew. And what we expect to see is a new IP address on VLAN 10's network, which should be 192.168.10.10, because that should be the first available address in that scope. And there we go. We grabbed 10.10 just like I thought, and our default gateway is 10.1. So we're now on our home VLAN. Now if we go over to a virtual machine that I have sitting on VLAN 55, we should be able to pull an IP from there. So here's the virtual machine that I assigned to, I believe, the Internet of Things VLAN that we just created. So if we do an IP config, you can see this, because it's just been sitting here, it doesn't have an IP, so we'll do a release and a renew. And it doesn't look like we're grabbing an IP, so let's go over to my other virtual machine, which is on the guest VLAN, and see if that one worked. So this one is actually a Linux machine, doesn't have a GUI. And you can see it was my Minecraft server. It's not anymore. If we do an if config here, oh, I mistyped that. Interface config, we should see, yep, right there, the ENP1S0. I can't highlight, sorry, but our address we pulled was 192.168.100.10. And if you don't remember where this PC actually sat, that's off that other trunk port I showed you. So if we go back here, and we do a show run interface port channel 1, this is that other trunk going to another switch. You can see we have switch port trunk allowed VLAN 50, 66, 77, 88, 99, and 100. So 100 is the VLAN that we're a part of, and it's trunking it over to that switch, and that virtual machine is assigned to VLAN 100. Now, why didn't the other computer work in the Internet of Things VLAN? Well, you're actually staring at the answer. It's because of the configuration on that trunk port. So if we do a show VLAN brief here, right under that, you can see that our Internet of Things VLAN is VLAN 55, and we are not allowing that VLAN to be tagged over that trunk. So we need to add VLAN 55. Technically VLAN 50 doesn't even exist, so enter configure mode, go to interface, port channel 1, and switch port trunk, allow VLAN add 55. Do a show run of that interface, and you can now see we have allowed VLAN 50 and 55 on this trunk port. So if we go back to our virtual machine for our Internet of Things VLAN, and we do a renew, so you can see the last time it said that we're unable to contact a DHCP server, request timed out. This time we should actually pull a valid IP from the Internet of Things VLAN. And there we go, 192.168.55.10. And that is how you set up VLANs in your home network with an Edgerouter. And even more bonus points if you own a Cisco switch, because you also saw those configurations as well, at least from the Catalyst series of switches. If you own one of the other like small business series, your configuration is going to be different. You don't really have the same command line as one of these full-blown dudes, but you know, the concept of assigning an access port or assigning a port of VLAN, putting a VLAN on the switch, and assigning it to a tagged port is the same across all managed switches. So just to recap, let's bring up our drawing board again. I know I kind of went through that pretty fast. If you're brand new to VLANs, you might still have some questions. So if you do have questions, just leave them in the comments. But basically what we did was we changed our interface configurations on our Edgerouter, added the VLAN interfaces, changed our trunk or tagged port configuration there, assigned our desktop to a VLAN. Now when I first drew this out, I had the other hosts hanging off of here, but in reality, we had another trunk to another switch with these two hosts hanging off of it over here. So we assigned one host over here's port to VLAN 55, the other one to VLAN 100, and we assigned this port of our desktop over here to VLAN 10. And we created all of these VLANs on the switch. You didn't see the configuration for this one over here, but it was the same. We assigned these VLANs to be allowed over this trunk, and we created our virtual interfaces with IPs up here on the Edgerouter. So 10.1, 55.1, and 100.1. And we also assigned a fallback interface in VLAN 1 to 2.1. Nope, that's off the screen. 2.1. So just to show some traffic flow here, something from the guest computer is going to come up, switch will see it. See it's assigned to VLAN 1, or 100 rather. It's going to assign that traffic a tag in VLAN 100 across the trunk link. This switch is going to accept it, see it's a part of VLAN 100, see that it has a VLAN 100, and it'll pass that through to its other trunk or tagged port link, send it up to our router with a tag of VLAN 100. The router will recognize that it has an interface looking for tagged traffic on VLAN 100 and put it under this interface and network and assign it a DHCP address in that pool since we configured one. And I realize I just used a really light colored ink there, so hopefully you can see that. Now, bonus points, if we put another PC over here and we assigned this port, or did no assignment on that port rather, would make it a part of VLAN 1. So his traffic would come in, untagged, Switch would see it was a part of VLAN 1. As long as VLAN 1 is allowed on this tagged port as the native, it will send it across the trunk or tagged link. Without a tag, this switch would see it, and if its native VLAN or untagged VLAN is VLAN 1 as well, it'll accept that into VLAN 1 and send that out the tagged port untagged again, and then hit the router whose port VLAN ID is 1, meaning that is the untagged VLAN, and be put under this interface. So hopefully that makes sense to you. Basically all VLANs are segregating traffic by assigning a tag to certain VLANs and configuring all equipment to recognize which tags are what and send them out interfaces that are allowed to be in that associated VLAN number. Now the main reason that we do all of this is to kind of segregate traffic. Sometimes we don't want the Internet of Things to have access to our home network, and we don't want the guests to have access as well. And the way we set this up, all of these are coming to a head on our Edgerouter, which just performs routing between each of these networks anyway. So with this configuration, our home network can access everything on the guest network, guests can access everything on home, as well as Internet of Things. They're all still able to access everything because we still have routing between all of them on the Edgerouter. And that's a topic for another video where we set up firewall rules to kind of segregate traffic, where the home network can access all of the other networks, but they are unable to access the home network. This kind of security is not created just by making VLANs. All we did was separate broadcast domains and network address spaces, which is necessary in order to have this kind of separation where we can put firewall rules in between them and really start locking down our network. So while the VLANs don't really offer this kind of security by themselves because we still have the routing, they do make it super simple to start adding in our security rules later. So be sure to watch out that video where I throw in the firewall rules here and actually lock down our networks. But for now, hopefully you learned something in here. Hopefully you can get VLANs set up on your router. And also hopefully you don't lock yourself out of your equipment. Like I said, it's pretty simple to actually get locked out of this if you go too fast, type in a wrong VLAN number or a VLAN where it shouldn't be. If everything doesn't align right, you can find yourself locked out of your equipment and needing to do a reset. So thanks for watching, and I hope to see you in the other videos.